Okay, on to question 4, which is the buffer overflow question. So given the fact that this page talks a lot about buffer overflows, you should go into a question like this knowing that there will be a buffer overflow. And so if you're not overwriting memory when there's a string input of some sort, you're probably doing something wrong. So make sure that there is something weird happening. It shouldn't just output what you would expect. So part A, explain the fundamental issue with C that makes buffer overflow exploit possible. This is C does not check bounds. No one should get this question wrong. It's an easy phrase to remember. That's the big vulnerability in C. That's what we want to remember about the C programming language, is it does not check bounds, which therefore allows this vulnerability. Okay, a buffer overflow exists in this program. Which information is at risk? Circle all that apply. Keep in mind that we can only write downward in memory, and we construct the stack from bottom to top. So, or from top to bottom in the program is going to be bottom to top on the stack. So anything that is after the program, after in program order, the vulnerable array, which is in this case going to be text, anything after that in program order is not going to be vulnerable. So in this case, Navy score is completely safe. We can't overwrite it. However, Army score is going to be below text on the stack. And so Army score is going to be vulnerable. And I've mentioned this to my class at least, but we don't consider text to be vulnerable because we're writing a program that allows a user to input something into text. So it is not actually at risk because we're allowing the user to change that information anyways. That's what they're allowed to change. Army score, we're not expecting them to be able to change that by overflowing from text. Okay. So part C, complete the stack on the right. Fill in the values stored in memory in hexadecimal and label all variables. So in this case, we just want to label everything here. So the first thing on the stack is going to be Army score. And that's going to take up 4 bytes of memory, right? Because an integer is 4 bytes. So Army score is going to take up 4 bytes. So 1, 2, 3, 4. The next thing on the stack, so again, we're reading the stack from top to bottom, and then we're going to put things on the stack from bottom to top. So Army score was first. The next thing in order in the program is text. Text is a character array that has 4 elements. So that's also going to be 4 bytes total. And then after that is Navy score. So Navy score is going to be higher in memory than text, and that's going to take up 4 bytes. So those are our labels. Each of these things is taking up 4 bytes in memory. Next up, we have to fill in the values stored in memory in hexadecimal and label all the variables. So we're assuming that we are at the point that everything has been entered into this, and we can kind of enter it in order. So we're going to assume that we entered 14 and 13 on this line that said enter the score of the Army-Navy game. We then see that we entered those into Army score and Navy score. So Army score is 14, Navy score is 13. So Army score should be stored here, and that should be the value 14. So 14 in hex is going to be OXOE, and then OX00, OX00, OX00. Keeping in mind that we store integers in little endian order, so the important byte, the byte that has information, is going to be at the top. The least significant byte is at the top. And so that means that the 14 is at the top of this. We're also going to store 13 in Navy score. So again, we're going to have OXOD for 13 in hex, and then a bunch of zeros. And again, we're storing this in little endian order so that the important byte, the byte that has information, is at the top. And finally, we're going to store text. So we can see that what happens here is we say if Army score is greater than Navy score, which 14 is greater than 13, we say, midshipman, are you sure Army won? Yes or no? We're expecting them to enter either yes or no, which would have fit into 4 characters for text. And they enter no, exclamation point, into text. So using our ASCII table that we have from the beginning of the test, we can figure out that no, exclamation point is going to be 4E, 4F, and then 2 exclamation points are going to be Let's see if we can find that on here. 21. So we're going to use 4E4F2121 as the hex values going in here. And we have to remember that this is a string input. So at the end of every string is a null terminator, which means that when we do this input, we're going to overwrite army score with a buffer overflow and change it to 0, 0 for that first byte. And that's because when we enter no, this is N, capital O, exclamation point, null terminator. So the null terminator is a buffer overflow into army score, and it just happens that that first byte is the one that had army's actual score. Now that's 0. So that's it for labeling the stack. Last, we have to figure out what is the exact output of printf in line 15. So we're going to print army, and in this case, army score has become 0. So army 0, comma, navy. Navy score has not changed, so that's still 13. And then we have some new lines around there, but it's not important in this case. Okay, so again, make sure on the buffer overflow question that you do actually see a buffer overflow. You know, we should overwrite some information at some point, like overwriting from text into army score. If you're not overwriting some information, that means you're probably not doing it quite right. That's it for that question. That's probably the toughest one.